32. Log base 8 of 32. And they gave you a hint for this problem, and they said, y'all are having conversations. Are they math related? Okay. Is it about this problem? Okay. Yeah. So this is 7.4b. We're looking at some problems we didn't get to the other day. So they gave you a hint. For each logarithm, log base b of x sub 1, rewrite b and x of powers of the same number. So you can do that. You can also do, remember that hint I gave you like when we very first started this, and I said, well, if you want to, you can just throw on an equals x there and then hamburger helper it. So what would this be, hamburger helper? And then we can use their hint easier, in my estimation, rather than having 8 as a base with exponents, which is awkward. Now if we rewrite 8 as 2 to the third, so 2 to the 3x equals 32, which is 2 to the 5. Now we have 3x equals 5, and it feels straightforward, 5/3. How about that? Better? So they're tricky little guys. Sometimes you have to figure out a way that it makes sense to you. That's how that would make sense to me. The point is that if I have this expression, 2 to the x equals 3, I can't solve it the same way I can solve this one where 8 has a base of 2 and 32 has a base of 2. I could sort of guess, right? It's not 2 squared, because 2 squared would be 4. That's too big. And it's not 2 to the first. I could say it's between 1 and 2, right? I could guess. Estimating is good. Guess x is between 1 and 2. Everybody gets that, right? 2 to the first is 2. 2 squared is 4. There's in that window. But I can't actually do that. So what this does is it gives me a way to get the x out of the sky and move it down to the ground. And what happens is, a long time ago, when I was in school probably, yeah, definitely. I don't think I got a TI anything until calculus, and maybe not even until college. So we didn't have a calculator that you could punch in log buttons. In Algebra 1 or pre-algebra, one or the other, you had to flip to the back. Do you remember looking up tables and stuff for square roots? So what somebody did was, seriously, that was their job to do math. They sat and they figured out what the square root of 3 was, and the square root of 5, and they estimated decimals, and they put it in a long table, and then they would print that, and people would go look up the square root of 5 because they didn't have a calculator. So now that we have a calculator, we can rewrite this in a math term. So the point is to rewrite it as log base 2 of 3 equals x, is to get this out of the superscript.
Would that be the answer?
So, and if we looked it up in a table, we could do that. Or if we find it in a calculator, we could find the exact decimal for it. But it's a way to say x equals, like to solve it. Because in algebra, we've been doing x equals 2, x equals 4, 0, whatever it is. This is a way to say x equals and have a mathematical representation for it. Even if I don't know what that is right off the top of my head, we did estimate it, but that gives me something to type in the calculator, basically, at this point in your lives. You're thankful that you don't have to look all these up in a table, because does anybody remember doing that in the book? It's not fun, right? Looking for that thing. And so anyway, the point is to get x out of the sky and be able to write it like a regular number. Logarithms represent exponents, but on the ground. Okay, so 55. Good? Okay, they gave a thumbs up, Sage. Here we go. 75. I worked really hard to not want to do that one because I kept saying the wrong number, but here we are, 75. All right, it says n to the 4/3 times n to the 2/5 all to the 1/6.
Yeah.
Okay. There's a couple of different ways we could do this. Max, do you want to, it has the same base, do you want to combine them on the inside first, or do you want to apply the 1/6 to both of these first? Like, it doesn't matter.
Well, I tried to apply
1/6 first. Okay, so that would be n to the 4/3 times 1/6 times n to the 2/5 times 1/6. Yeah?
Yeah.
So what is that actually going to be? I'm going to make that n to the 2/9. 2 goes 2 and 3 times 2/9. There's like a whole bunch of you that can check my stuff. Is that good?
Yeah.
Okay. And then times 2 to the 2 to 15. That's gross. I'm not sure that was the best choice, but I wouldn't have known that until we worked it out. Because now what do I have to do to add these up? We got to get a common denominator. So the rule is same base, add the exponent. So we now need to say 2/9 plus 1/15. Can I see this color? Nope. So what's my common denominator?
45.
Ooh, goody. Thank you. 45. So this one needs a 5. This one needs a 3. So I've got 10 plus 3 over 45. How about that? So I have n to the 13 over 45. 75. Yep. Yay, that was the answer. Did I write it down wrong the other way? Or did we just need to work it out? Okay. So it didn't actually matter. There wasn't as much, I mean, the order of operations probably would have said, hey, y'all should have done this first. But it didn't matter in this case. Either way, if we'd have put them together and then applied the 1/6, either direction is fine. 75. Other questions from the night before homework, because y'all had more, and I said, try them again. Here are the answers. They're posted. Go. No? Okay. All right. So now we're going to look at properties of logarithms. And some of you have already done that homework, so you're just going to follow along and let me know what questions you have, because it took me a long time to redo the assignment so that it said for tomorrow. And by the time I got there, people had already turned it in, so I couldn't like redo it because I didn't want to take away the people who'd already done it. So good job, people who did stuff in advance. But that video is already posted, so you can watch that again if you want. I'm going to stop this video now. Okay, bye.